Hi there, welcome to my presentation on data centers, cloud computing, and security. Even though I've been using technology since I was a child and I currently use the cloud, I was definitely ignorant to how data storage and transmission worked. Deep diving into this project shed some light on the subject and pointed out things I had never considered before, like the immense security measures in place. All right, let's dive in. We'll start with the foundation. What exactly is a data center? In Sussenhara and Smalley's article, What is a Data Center?, they describe it as a physical room, building, or facility that houses IT infrastructure for building, running, and delivering applications and services. It also stores and manages the data associated with those applications and services. To give you a sense of scale, centers in Loudoun County, Virginia alone handle approximately 70% of the world's internet traffic. That's an astonishing concentration of digital information flowing through a single region. While they may seem like a modern innovation, data centers actually date back to the 1940s, though the machines were significantly larger then. What once required an entire building to process simple calculations can now be accomplished with devices that fit in our pockets. Building on data center infrastructure, cloud computing has revolutionized how we access and utilize computing resources. Sussenhara and Smalley define it in their article, What is Cloud Computing?, as on-demand access of computing resources over the internet with pay-per-use pricing. Cloud computing began in the early 2000s and has transformed digital opportunities by giving individuals and organizations access to immense computing power and storage without needing to own or manage the physical hardware themselves. For businesses, including research facilities, cloud computing provides greater flexibility and scalability while being cost-effective. You can rapidly increase resources during intensive analysis phases and scale back during quieter periods, paying only for what you use. With these powerful technologies comes significant responsibility, particularly around security. One of the most important concepts to understand is the shared responsibility model. Both the cloud provider and the customer have specific security obligations. The customer protects the data within the cloud, while the provider secures the cloud's infrastructure. Data encryption is essential, ensuring that information remains protected while in use, in transit, and at rest. Security requires collaborative management between IT teams, operations, and security teams for seamless and stable integration. Everyone plays a role in maintaining a secure environment and must understand the compliance standards within their industry and have active monitoring. Other critical security components include identity and access management to control who can access what information, data loss prevention strategies to safeguard all data, security information and event management systems that provide comprehensive oversight of the digital environment, and automated data and compliance platforms to keep organizations up to date so they can adhere to industry regulations and standards. In Google Cloud Tech's YouTube video, Google Data Center Security, 6 Layers Deep, Stephanie Wong tours a physical Google data center. As she goes through, the many levels of security are explored along with their features. I had never considered the security measures needed for a data center like this, so this video was a bit surprising to me, but very informative. Level 1 pertains to the property boundaries indicated by signage and fencing. Level 2 is the secure perimeter. This includes the main entrance gate, standard and thermal cameras, and guard patrols. Level 3 is all about building access. Badges, an iris scanner, and protocols where only one person can badge into a door at a time. Level 4 is the SOC, or Security Operations Center. This is the brains of the system and where everything is being monitored 24/7, 365 days a year. Level 5 is the actual data center floor and has as-needed access. Workers have access to the devices, but all the data is encrypted and secure. Finally, level 6 is where disks and data are destroyed. Access is incredibly limited, and only workers assigned to this level can enter. Equipment that needs to be erased or destroyed is passed through a two-way locker system that only those technicians can access. Now let's explore how these technologies specifically relate to laboratory animal research, which is the industry I work in. Data centers and cloud computing enable the storage and processing of massive data sets from high-resolution imaging and continuous monitoring systems. Think about the terabytes of data generated from MRIs, CT scans, and 24/7 behavioral monitoring of research subjects. One of the most significant benefits is the reduced need for repeated studies. With better data management and accessibility, researchers can extract more insights from existing data, helping to align with the 3 R's principle of reduction, refinement, and replacement in animal research. Cloud-based applications have been developed specifically for animal colony management and protocol submission and review, streamlining administrative processes and improving oversight. Data centers, cloud computing, and security technologies are transforming laboratory animal research in profound ways. As we look into the future, we can expect continued innovation in how these technologies support research. AI-powered monitoring systems, real-time collaboration across global research teams, and enhanced security protocols will further advance our capabilities. The responsible implementation of these technologies allows us to conduct more humane, efficient, and productive research while maintaining the highest standards of data security and integrity. This last slide contains all the references I used in this project, and that concludes the presentation. Thank you for listening.